Welcome to Black Hole Basics. Today, we explore the hidden mysteries of our vast universe and uncover its deepest, darkest secrets. For centuries, humanity looked up at the night sky and imagined a completely empty void separating the glittering stars above us. However, modern physics reveals a completely different reality, showing that the cosmos is actually filled with an invisible, dynamic structural grid. This unseen architecture is known as spacetime, a revolutionary concept that forever changed how we understand the mechanics of the cosmos. Imagine a gigantic, flexible trampoline stretching infinitely in every direction, representing the invisible fabric that connects everything in our known universe. When a massive object like our sun is placed onto this cosmic trampoline, it creates a deep depression in the fabric. This bending of space is what we experience as gravity, an invisible force guiding the movements of planets and distant galaxies. The Earth does not orbit the sun because of an invisible tether, but because it follows the natural curve of space. Think of a heavy bowling ball resting on a mattress, causing smaller marbles to naturally roll toward the deep central dip. In this exact same way, planets simply travel along the straightest possible paths through a fundamentally curved and warped cosmic environment. This brilliant realization came from Albert Einstein, who completely rewrote the laws of physics with his general theory of relativity beforehand. Before Einstein, Isaac Newton described gravity as a mysterious pulling force acting instantly across vast distances without any clear physical mechanism. Newton could perfectly calculate how strong gravity was, but he never truly understood what actually caused this invisible attraction between objects. Einstein solved this ultimate mystery by proving that space and time are permanently woven together into a single, flexible cosmic tapestry. Every single star, planet, and asteroid in the universe constantly interacts with this space-time fabric, shaping it and being shaped simultaneously. As massive celestial bodies travel through the freezing depths of space, they continuously drag and warp the invisible fabric around them. This means the universe is absolutely not a rigid, static background, but rather a living, breathing entity that constantly changes shape. Some of the most extreme deformations in spacetime occur around black holes, where gravity becomes so incredibly strong nothing can escape. When a dying star collapses under its own immense weight, it punctures the spacetime fabric, creating an infinitely deep gravity well. These fascinating cosmic monsters warp reality so severely that time itself begins to slow down significantly near their dark, mysterious edges. If you were to bravely approach a spinning black hole, you would physically experience the ultimate distortion of space and time. The invisible fabric of our universe is constantly vibrating, shaking, and undulating in response to the massive cosmic events happening everywhere. When two incredibly dense objects like black holes violently collide, they release unimaginable amounts of energy directly into the spacetime fabric. This catastrophic cosmic collision generates powerful ripples known as gravitational waves, which travel outward at the exact speed of light itself. These invisible ripples squeeze and stretch everything they pass through, including our own planet Earth, and every single person living here. Einstein mathematically predicted the existence of these elusive gravitational waves over 100 years ago, relying purely on his brilliant equations. For many decades, scientists desperately tried to build machines sensitive enough to detect these incredibly tiny distortions in the spacetime fabric. The challenge was absolutely monumental because by the time these cosmic waves reach Earth, they are smaller than a single proton. To catch these ghostly vibrations, researchers constructed the Laser Interferometer Gravitational Wave Observatory, a massive scientific instrument known simply as LIGO today. LIGO uses perfectly tuned laser beams traveling down incredibly long vacuum tubes to measure minuscule changes in the distance between mirrors. In September 2015, the scientific world changed forever when LIGO successfully detected the very first gravitational wave passing through. This historic signal perfectly matched the theoretical predictions of two massive black holes merging together over 1 billion light-years away. Hearing the faint cosmic chirp of this collision proved beyond any doubt that our universe is a highly dynamic, flexible structure. This groundbreaking discovery officially opened an entirely new window into astronomy, allowing us to finally listen to the universe itself speaking. We are no longer limited to merely looking at distant starlight. We can now feel the actual heartbeat of the cosmos. Every time a major cosmic event occurs, new waves are generated, sending vital information across the vast emptiness of deep space. Scientists are currently building even more advanced detectors to capture these subtle vibrations from the farthest reaches of our known universe. Future space-based observatories will eventually detect the gentle hum of countless merging galaxies, revealing secrets from the dawn of time itself. The fabric of spacetime is essentially the ultimate cosmic ocean, and we are just beginning to study its majestic, rolling waves. As we continue to explore these profound mysteries, we realize how deeply connected we are to the fundamental structure of reality. The atoms in our bodies are constantly riding the invisible waves of gravity that wash over our planet every single day. Understanding spacetime helps us comprehend the true nature of existence, bridging the gap between abstract mathematics and observable physical reality seamlessly. Gravity is not just a force that keeps our feet planted firmly on the ground. It is the geometry of space. When you drop a simple apple, it falls downward because it is naturally following the curved contours of the space-time fabric. This beautiful geometric perspective allows us to accurately map the intricate cosmic dance of galaxies, stars, and planets across the void. Even light itself is forced to bend and curve when it passes near a massive object that has warped the spacetime. This fascinating phenomenon is called gravitational lensing, and it allows astronomers to use massive galaxy clusters as giant natural magnifying glasses. By studying how starlight bends around these massive cosmic structures, we can map the distribution of invisible dark matter in space. Dark matter remains one of the greatest unsolved mysteries in physics, making up most of the mass in our expanding universe. Although we cannot see dark matter directly, we can easily observe its powerful gravitational pull on the flexible fabric of spacetime. Without the extra gravity provided by this mysterious substance, entire galaxies would simply fly apart and dissolve into the empty void. The universe is a delicate balancing act of massive forces, all playing out on the invisible stage of the spacetime fabric. As the universe continues to expand at an accelerating rate, the very fabric of space is being stretched thinner and thinner. This mysterious expansion is driven by dark energy, an unknown force that pushes galaxies away from each other across vast distances. The ultimate fate of our universe depends entirely on the ongoing epic battle between the pull of gravity and dark energy. If dark energy ultimately wins, the fabric of spacetime could eventually tear apart in a catastrophic event called the Big Rip. However, if gravity regains control, the entire universe might eventually collapse back in on itself in a fiery, dramatic big crunch. Currently, all observations suggest that the universe will simply continue expanding forever, slowly growing colder and darker over trillions of years. Despite this seemingly bleak future, the present moment offers us an incredible opportunity to study the magnificent mechanics of the cosmos. We live in a privileged era where human technology has finally caught up with the brilliant theoretical ideas of past generations. The detection of gravitational waves is just the beginning of a magnificent new chapter in our ongoing quest to understand reality. Every single day, brilliant scientists around the globe are working tirelessly to unlock more secrets hidden within the fabric of spacetime. They use massive supercomputers to simulate complex cosmic events, visualizing how black holes and neutron stars interact with their surrounding environments. These incredibly detailed simulations help researchers predict exactly what future gravitational wave signals will look like when they finally reach Earth. By comparing these mathematical predictions with actual observational data, we can continuously refine our understanding of how the entire universe operates. The laws of physics are the ultimate rulebook of nature, dictating how matter and energy flow through the vast cosmic arena. Einstein's general theory of relativity remains one of the most successful and rigorously tested scientific theories in the history of humanity. Yet, Scientists know that this incredible theory is not entirely complete, as it famously clashes with the bizarre rules of quantum mechanics. Finding a unified theory of quantum gravity is the ultimate holy grail of modern physics, promising to merge these two worlds. Such a revolutionary breakthrough would finally explain how the fabric of spacetime behaves at the absolute smallest microscopic scales imaginable today. String theory and loop quantum gravity are two fascinating mathematical frameworks attempting to solve this monumental puzzle of modern theoretical physics. These advanced theories suggest that spacetime might actually be composed of tiny, discrete building blocks, rather than a completely smooth continuum. Imagine zooming in on a digital photograph until you can clearly see the individual square pixels that make up the image. In a similar way, zooming in on empty space might eventually reveal the fundamental, pixelated structure of the spacetime fabric itself. Proving the existence of these quantum pixels would require particle accelerators far more powerful than anything currently existing on our planet. Until then, we must rely on the subtle clues provided by extreme cosmic environments, like the chaotic centers of black holes. Deep inside a black hole lies the singularity, a mysterious point where gravity becomes infinite and our current physical laws break. Understanding the true nature of the singularity could provide the missing link needed to finally combine general relativity with quantum mechanics. This quest for knowledge drives humanity to build bigger telescopes, launch better satellites, and push the boundaries of our technological capabilities. We are a curious species, forever driven by an innate desire to comprehend the vast, beautiful universe that we call home. The story of spacetime is essentially the story of us, reflecting our enduring struggle to make sense of the natural world. From the ancient philosophers staring at the stars to modern physicists analyzing complex quantum data, our cosmic journey has been remarkable. We have learned that emptiness is an illusion, and that every inch of the universe is pulsing with invisible, dynamic energy. The space between the stars is not a barren wasteland, but a vibrant, fluctuating medium that carries the whispers of creation. Gravitational waves are the ultimate messengers of the cosmos, delivering vital news from the most violent and energetic events ever recorded. When we detect these subtle ripples, we are literally feeling the distant echoes of ancient stars colliding in the dark void. It is truly mind-boggling to realize that an event happening billions of light years away can physically stretch and squeeze us. This profound interconnectedness reminds us that we are not separate from the universe, but rather an integral part of its fabric. The very iron in our blood was forged in the fiery hearts of dying stars that exploded billions of years ago. Those massive stellar explosions also sent powerful gravitational waves rippling across the cosmos, shaping the evolutionary path of countless distant galaxies. In a very real sense, we are made of stardust, and our existence is deeply tied to the mechanics of spacetime. As we look toward the future, the exciting field of gravitational wave astronomy promises to reveal completely unexpected and thrilling discoveries. We might soon detect the faint, lingering vibrations from the Big Bang itself, giving us a glimpse of the universe's birth. These primordial waves could finally answer fundamental questions about how our vast universe rapidly expanded during its very first chaotic fractions. The cosmos is a grand, magnificent symphony, and we have finally developed the right instruments to hear its beautiful, hidden melodies. Every new scientific discovery adds another rich layer of complexity and profound beauty to our ever-evolving understanding of the natural world. We must continue to support bold scientific exploration, encouraging the next generation of curious minds to ask difficult and challenging questions. The mysteries of spacetime are vast, but human ingenuity has proven time and again that no puzzle is entirely beyond reach. By working together across borders and disciplines, scientists can unlock the deepest secrets of the cosmos and elevate our collective consciousness. The invisible fabric that binds the universe also binds us together in our shared pursuit of truth, knowledge, and scientific discovery. Let us take a moment to truly appreciate the sheer scale and unimaginable majesty of the dynamic universe we inhabit today. From the smallest subatomic particles to the largest superclusters of galaxies, everything is perfectly orchestrated by the elegant laws of physics. The cosmic web of dark matter and luminous gas stretches across billions of light years, forming a breathtakingly beautiful structural masterpiece. Within this immense cosmic web, countless galaxies slowly rotate, constantly giving birth to brilliant new stars in massive clouds of dust. Each of these glowing stars heavily warps the spacetime fabric around it, creating a complex, undulating landscape of invisible gravitational valleys. Planets perfectly navigate these steep invisible valleys, maintaining stable orbits that allow complex chemistry and beautiful life to eventually flourish peacefully. Our own precious Earth is a rare and fragile oasis, floating gracefully through the immense, dark, and freezing ocean of spacetime. The delicate balance of forces that allows us to exist is a testament to the remarkable precision of our universe's mechanics. If gravity were even slightly stronger or weaker, the stars would never have formed, and the universe would be completely dark. This incredible fine-tuning of the cosmos is one of the most fascinating philosophical puzzles that modern physicists continue to debate today. Some scientists propose the existence of a vast multiverse, where countless different universes exist with their own unique laws of physics. In this mind-bending scenario, our universe simply happens to have the exact right conditions required for intelligent life to successfully emerge. While the multiverse remains a purely theoretical concept, it highlights the boundless imagination that drives human scientific inquiry forward every day. We must never lose our sense of wonder as we gaze up at the countless glittering stars scattered across the night. Every point of light represents a distant world, a unique story playing out on the vast, invisible stage of the cosmos. The universe is not a static, boring museum of dead rocks. It is a vibrant, chaotic, and relentlessly active cosmic laboratory. Black holes collide, massive stars explode, and the very fabric of reality constantly ripples with the raw, untamed energy of creation. We are incredibly fortunate to live in a time when we can actually perceive and measure these magnificent, invisible cosmic phenomena. The legacy of Albert Einstein lives on in every laser beam fired through the vacuum tubes of modern gravitational wave detectors. His brilliant mind fundamentally changed our perception of reality, proving that human thought can penetrate the deepest mysteries of the universe. As we continue to build more sensitive instruments, we will undoubtedly uncover new phenomena that will challenge our current scientific models. Science is a perpetual journey of discovery, where every answered question inevitably leads to a dozen new and exciting profound mysteries. The fabric of spacetime still holds countless secrets, waiting patiently in the dark for curious human minds to finally illuminate them. Perhaps one day, we will learn how to manipulate spacetime itself, unlocking the futuristic dream of faster-than-light interstellar cosmic travel. Bending the fabric of reality could theoretically allow us to instantly cross the unimaginable distances separating us from distant star systems. While this remains firmly in the realm of science fiction today, the history of science shows that impossible dreams often materialize. For now, we must remain humble observers, carefully studying the beautiful ripples and intricate curves of our fascinating, dynamic cosmic home. The universe is speaking to us through the subtle, invisible vibrations of gravity, and we are finally learning how to listen. Every ripple in spacetime carries the profound story of our cosmic origins, reminding us of the magnificent power of physical laws. We stand on the precipice of a new era of understanding, ready to dive deeper into the vast ocean of reality. The journey of scientific exploration is endless, fueled by our unyielding curiosity and our deep desire to comprehend the magnificent cosmos. Thank you for joining us on this incredible journey through the invisible, warping fabric of spacetime that shapes our entire universe. We hope this exploration has expanded your mind and deepened your profound appreciation for the intricate mechanics of our cosmic reality. Stay curious, keep looking up at the stars, and never stop questioning the fundamental nature of the beautiful world around you. This has been Black Hole Basics. Please subscribe for more fascinating cosmic adventures. and we will see you in the future.